As we told you earlier, it's important for the oil in your EMD to stay in good shape. So we're going to take a look at the lube oil system. We'll show you how it's all put together and some of the things to look for when servicing the engine. The lube oil system actually has 3 separate systems that work within it. First is the main lubricating system, then the piston cooling system, and finally the scavenging oil system. Each of these systems has its own pump. 2 of these pumps, the main lube oil pump and the piston cooling oil pump, are located in the same place and are driven by the same drive shaft. And all of these pumps are driven from the accessory drivetrain at the front of the engine. How about we take a look at how the oil gets through the engine? First, the oil is brought up from the pan sump and into the strainer housing, where it goes through the scavenging oil strainer. From here, the scavenging oil pump sucks the oil in and forces it up to the lube oil filter. After circulating through the oil filter, the oil travels up to the lube oil cooler. Once the oil has been cooled, it goes back down to the strainer housing and through the main lube and piston cooling oil strainers. Here's where the piston cooling and main lube oil pumps take over. They pull the oil up into the pumps, and from there the piston cooling oil pump sends the oil to the piston cooling oil line through the carrier to cool the piston undercrown and the ring belt area. Some of the oil goes into the oil grooves in the piston pin bearing, and the rest of it drains out through holes in the carrier skirt to the oil pan. Now, the main lube oil pump sends oil to the lube oil manifold, where some of it goes into oil tubes to lubricate the main and connecting rod bearings. The rest of it goes to the back of the engine and lubricates the turbocharger. From there, the oil goes up the camshaft and on to lubricate the moving parts in the upper deck. Now let's take a look at some of the things to keep an eye on in the oil system. On the side of the engine is an oil level gauge which sticks down into the oil pan sump. You should keep the oil level between the low and full marks on the gauge, and the readings need to be taken while the engine is at idle speed and the oil is hot. Keeping the oil pressure up in the engine is very important, and it's not adjustable. The minimum oil pressure should be 8 to 12 psi when it's at idle speed and 25 to 29 psi when it's at full speed. Now remember, these are minimum readings for your oil pressure. You can keep an eye on the oil pressure by taking off the pipe plug at the piston cooling discharge elbow and putting in an oil gauge. If the oil pressure isn't high enough, the governor will automatically shut the engine down. And if it's too high, this relief valve, set at 125 psi, will release and let the oil go back to the oil pan. You can also check the piston cooling oil pressure by putting the gauge at the piston cooling discharge elbow. If you run into any problems with the lubricating system, it might be because of a couple of things. If there's no oil in the strainer chamber, you might have a scavenging system that's not working, or an open drain valve. If the scavenging system isn't working, it could be because of broken or loose oil line connections. The strainer may not be properly seated, which could cause an air leak, or you could have a faulty scavenging pump, clogged strainer, or even low oil level. If the oil pressure is low, you could have a relief valve that's stuck open. If so, check the relief valve seat for any dirt or other objects. Other problems you might have are a broken line, clogged strainers, extra wear on the bearings, low oil viscosity, faulty pump, diluted oil, or not enough oil in the strainer housing. If the pump isn't working, it might be because of sheared pump gear keys, broken housing, or damaged gears. If the oil is diluted, you could have fuel leaking into the lubricating oil. Check to see if the fuel line connections to the injector are loose or broken, or if the injector is bad. If you think that the lube oil is diluted, you need to check the viscosity. If the engine seems to be using a lot of oil, there's a number of things you need to check. You might have oil leaks, broken or stuck piston rings, worn cylinder liners, clogged oil separator screen, the wrong grade of oil, or clogged oil drain holes under the piston oil control rings. If the engine doesn't seem to be using enough oil, it might be because the oil is diluted due to water or excess fuel oil leaking into the lubricating oil. Earlier, we said that the main lube oil and piston cooling oil pumps are located in the same housing and driven by the same drive gear. Well, this spacer, right here, separates the two pumps, and each one of them has its own inlet and outlet openings. Whenever you need to take the pump apart to look at or fix it, always be sure to clean the outside real good before working on it. Now let's talk about one of the most important things in the chain, the lube oil pressure relief valve. It's located here. The purpose of this valve is to limit the maximum pressure of the lubricating oil to the engine oil system. If the pressure is more than 125 pounds per square inch, the valve in the relief valve will raise up and allow oil to come into the relief valve and go back to the oil pan. If you have problems with the valve and need to check it, it should be taken apart and all the parts washed. One thing to remember here is before taking off the valve holder and spring, always back off on the valve guide all the way. From here, the parts can be inspected. You need to check the valve spring to make sure it's working correctly and test it by putting a load of 310 pounds on it. By doing this, the spring should not be less than 4 1/2 inches. By using this telescoping gauge, you can check the valve guide inside diameter. If it's rough or lightly scuffed, you need to clean up the bore, but make sure it doesn't go over the maximum diameter, which is 0.5025 inches. The other thing you need to check is the valve stem. If it is rough or scuffed a little, it can be hand-stoned and buffed. Another thing you need to check for is if the valve stem is badly galled. You need to replace it. Also, check that the valve stem is at least 0.4925 inches in diameter. Check the squareness of the valve face to the stem. Here, you need to measure it from the outer edge of the valve face. Your reading shouldn't be more than 0.002 inches. Now, before putting the relief valve back in, always be sure that the bypass port is turned away from the crankcase end plate. To set the oil pressure on the relief valve, just loosen the lock nut so that the valve guide sticks out 1.5 inches above the safety plate. This will make it so that you have a maximum oil pressure of 125 psi when the oil is cold. It will also allow the correct amount of oil pressure when the oil is hot. Now that brings us to the piston cooling oil pipe. It's connected from the flange on the manifold to the bottom of the cylinder liner. There is a pipe at each cylinder which sends oil through the piston carrier to the top of the piston. Alignment of the piston cooling oil pipe is very important, so in order to make sure the piston cooling oil pipe is in alignment with the inlet hole at the piston carrier, we use this alignment gauge. The small end of the gauge fits into the nozzle of the pipe, and if you bring the piston to bottom center, the gauge should enter the inlet hole and be able to turn freely. This gauge is for alignment only. Don't be using it to bend the pipe in case the pipe is not correctly aligned. When you're checking the alignment, and if the alignment gauge doesn't turn freely in the inlet hole, that means that the pipe needs to be replaced. The other thing that needs to be checked is the nozzle itself. If it has any ragged edges, this could cause the oil to come out in a spray instead of a jet directly into the inlet hole. Now let's check into the oil viscosity. You need to keep an eye on this and check it every time you take a lube oil sample. By checking the oil viscosity at regular intervals, when the engine is at the same oil temperature, you can detect any unusual drop in viscosity. If the viscosity has an unusual rise to it, it could be because of extra oxidation of the oil. The viscosity is affected by the type of oil you're using and also by the measurements that you're making. If the oil is badly oxidized or if there's poor filtration, the oil cooler core could be plugged. You could get carbon buildup on piston undercrowns, ring grooves, oil rings, and piston pin bearing grooves. Or you could limit the oil flow to the main and connecting rod bearings, which could damage the engine. So you obviously need to keep a close eye on the oil. There's a lot of oxidizing going on, and also contaminants can get into the engine if the filtration system isn't working correctly. You'll need to change the oil every 4,200 hours, or earlier if the oil looks like it needs changing. If you need to know how to change the oil, go to the program 4,200 Hour Maintenance Tasks. The steps on changing the lube oil are laid out in this show. There are a few parts in the lube oil system which have been covered in another program, and they are the oil strainer housing, the turbocharger oil filter, the lubricating oil filter, and the auxiliary turbocharger oil filter. If you need to know how to service any of these parts, watch the program 1400-Hour Maintenance. It'll give you all the information you'll need. The procedure we're about to show you on how to disassemble and reassemble a main lube and piston cooling oil pump is for a pump found on an 8 or 12-cylinder engine. The steps for taking a pump apart on a 16 or 20-cylinder engine are about the same, but there are a few differences. If you need to know how to take one of these apart, go back to Section 9 of your EMD manual and follow the steps laid out for disassembly and reassembly of a pump on a 16 or 20-cylinder engine. Now, if you need to take the main lube and piston cooling oil pump apart and look at it or fix it, the first thing you need to do is to get something that'll hold the pump. This is a specially made device used to hold pumps. The front of the pump is bolted directly onto the stand. If you don't have anything like this, just use a vise. But one thing to remember is if you're going to use a vise, you should put something underneath the middle of the pump in order to give it a little extra support. Now, take out these bolts and remove the cover plate to the piston cooling pump. Now you need something to hold the main gear steady while you're loosening the shaft nut. Here we're using an old piece of a gear that's been adapted for this purpose. It just slides onto these two little bolts here and holds the main gear steady while working on the pump. Now loosen the shaft nut and take it and the washer off. Up here we have the idler shaft lock bolt. It needs to be taken out before you can take off the piston cooling oil pump body. Then loosen these bolts, which hold the piston cooling oil pump housing, to the main lube oil pump housing, and take off the piston cooling oil pump housing. It should be a good tight fit, so you may need a little something to help you pry the two loose from each other. Once you've got the housing off, take off the shaft sleeve, then the idler gear, and now the drive shaft gear. The drive shaft gear may be a little bit more difficult to take off, so just use a rawhide mallet and tap the drive shaft, and that should loosen it up and you'll be able to take it off from that point. The next thing to come off is the gear key. Use some sort of large punch or maybe a dull-in screwdriver and a hammer and tap it out. Now take off the spacer plate and slip off the spacer sleeve, then the idler shaft, the main lube oil pump idler gear, and the main lube oil pump drive gear. Once again, it may be necessary to tap the drive shaft in order to loosen up the drive gear to take it out. Now you've got to take out the gear key of the main lube oil pump drive shaft. These gear keys are supposed to be a nice snug fit, so sometimes you might have a little difficulty getting it out, but it'll come out sooner or later. Just be patient. The last thing to do is slip out the drive shaft and gear. One important thing to remember is to keep all of the same parts of the one pump together. Each part of the pump is made specifically for that pump, and the part may not fit quite right in another pump. So keep the parts together out of the same pump. Clean all the parts in a petroleum solvent and then dry them with compressed air. Now you need to inspect the parts of the pump. Check the surfaces of the pump body. If they're not smooth, get an abrasive cloth of some sort and try to remove some of the rough spots. Make sure all the bore sizes are within the maximum limits allowed by your EMD manual. Check the spacer plate for any rough spots on it. If you find any and need to smooth them down, use some sort of flat piece of wood, like we're using here, or some tool that has a flat surface, and put the abrasive cloth around that surface and sand out any of the spots. This will keep the surface of the spacer plate flat. Use the same procedure whenever you're checking the gasket surfaces on the pump bodies. Check the gear teeth to make sure they don't have any extra wear or any nicks or pitting in them. It's all right if they have little nicks on them, but if they're more than 30% pitted on the tooth contact area, they should be replaced. Check the keys in the keyways for a nice snug fit. And also, check the drive shaft and the idler shaft for any nicks and scratches. You need to check the drive shaft diameter. Make sure it's within the limits allowed by your EMD manual. To put the pump back together again, you put it back in the holder or the vise and lubricate the inside of the main lube oil pump housing. And also, all of the other parts need to be lubricated before putting them back together again. Now, you need to put the drive shaft and the main gear back into the body pump housing. Then, put in the main lube oil pump gear key. Slip on the main lube oil pump drive gear. Make sure this slot right here slips over the key in order to hold the drive gear in the correct position. Then, the idler shaft needs to be put into the main lube oil pump housing. Then, slip the idler gear over the idler shaft. Now, lubricate the gasket surface on the main lube oil pump housing and put the gasket into place. Be sure to line up the bolt and dowel holes on the gasket correctly with the gasket surface on the main lube oil pump. The next thing that needs to go on is the spacer plate. Brush it down good with lubricating oil and slip it over the drive shaft and the idler shaft and into place against the gasket surface of the main lube oil pump. Then, the other gasket should be placed onto the spacer plate. Now, slip the spacer plate sleeve over the drive shaft. Then, tap the piston cooling oil pump gear key into place and slip the piston cooling oil pump drive gear over the drive shaft and key. This little dowel end on the idler shaft lock bolt fits into this hole in the idler shaft. So, before putting the idler gear on and the piston cooling oil pump housing on, that hole in the idler shaft needs to line up correctly with the hole in the piston cooling oil pump housing that the idler shaft lock bolt goes into. Now that the idler shaft is in correctly, put on the idler gear, then lubricate the inside of the piston cooling oil pump housing and slip it into place onto the drive shaft and idler shaft. Now put the idler shaft lock bolt into place and tighten it down. Then, the piston cooling oil pump housing needs to be bolted to the main lube oil pump housing. One thing to watch here is the bolts that you're using. Some of them are slightly longer than others and belong in a different spot. There are 4 of each. The 4 middle ones right here are the longer bolts and need to go into these positions. Then, torque down all the bolts to approximately 65 foot-pounds. Now, slip the shaft sleeve into place over the drive shaft and put the shaft washer and nut into place, and then tighten down the nut and torque it between 325 and 350 foot-pounds. The last thing to go on is the cover plate, and don't forget to put on a new gasket here. This also has some long bolts and some short bolts. The 3 bottom ones are the long ones, so make sure they go into the right place also. There's one final thing that needs to be done, and that's to wire the idler shaft lock bolt to the bolt on the cover plate that has the hole in it. This is so that while the pump is running, it does not vibrate the lock bolt out of its place. After the pump's been put back together, you'll need to make sure that it's back together right. Rotate the pump drive gear to check for any gear noise and for a tight assembly. Now you need to check the thrust of the drive gears. To do this, get an indicator like this one. Put it on the pump flange and make sure this indicator button is on the rim of the pump drive gear. Push the drive gear in so that all the clearance is at one end. Then set the indicator to 0. Pull out the drive gear to check the amount of thrust clearance, which is between 0.005 inches and 0.022 inches. Leave the indicator in place and rotate the drive gear to check the runout. This runout should be a maximum of 0.003 inches. Also, check the pump flange runout. Put the indicator clamp on the drive gear and place the indicator button so it contacts the pump flange. Set the indicator to 0 and, with the thrust held in one direction, rotate the drive gear. The runout here should not be more than 0.005 inches. And finally, check the pump gears to body radial clearance. It should be between 0.0015 and 0.010 inches. Now on to the scavenging oil pump. It's basically the same as the main lube and piston cooling oil pump. It's got the same type of pump drive. It's got a drive shaft, the idler shaft, the drive gears and the idler gears, as well as a shaft bolt and washer and shaft sleeve. It even has its own idler lock bolt. If you need to take this pump apart, follow the same procedures as laid out when we were talking about the main lube and piston cooling oil pump. As on the main lube oil and piston cooling oil pumps, the scavenging pump cover plate nuts need to be torqued down to approximately 65 foot-pounds, and the shaft nut needs to be torqued down to between 325 and 350 foot-pounds. Once the parts have been lubricated and put back together in the pump, the fuel pump needs to be put onto the scavenging pump. Then check the thrust and runout of the scavenging oil pump, following the same procedures as laid out in the main lube oil and piston cooling oil pump. The thrust clearance on the scavenging oil pump should be between .008 inches and .022 inches. The drive gear runout should not be more than .003 inches, and the pump flange runout should not be more than .005 inches. The last thing to check is the pump gear to body radial clearance, and it should be between .0015 and .010 inches. Now let's take a look at the soakback oil system. This is there as a kind of protection for the engine and the turbocharger. What it does is pump oil through the turbocharger bearings before the engine is started up and after the engine shut down to remove any of the heat in the bearing area. It's controlled automatically through the engine's start and stop controls. The way this system works is this pump right here draws oil from the oil pan and pumps it through an oil filter, and then through the head of the turbocharger oil filter, and then directly into the turbocharger bearing area. This pressure relief valve right here is set at 55 psi. When the engine starts up, the soakback pump motor will still be running. When the oil pressure from the engine gets up to 55 psi and there's no outlet for the lower pressure oil, the relief valve will open up and let the low pressure oil go back to the oil pan. And if a filter element gets plugged, there's this bypass valve which is set at 70 psi. It'll let the motor-driven pump pressure bypass the plugged filter so that it can lubricate the turbocharger. The filter element needs to be serviced every 1400 hours. If your EMD has an immersion heater, then you'll have a lube oil circulating pump instead of a soakback pump and motor. This pump does everything the soakback pump does, plus it circulates oil through the lubricating oil system to keep an engine that's been in standby status ready to start up at any time you need it. The way it keeps the oil ready for an immediate startup is it pumps the oil through the cooler, and warm water is pumped through the oil cooler passages from the immersion heater. The way this system works is the pump draws the oil up from the oil pan and pumps some of it through the turbocharger lube oil filter and then into the turbocharger bearing area. The rest of the oil is pumped through a 30 psi check valve, through the main lube oil filter, into the oil cooler, and then it goes back to the oil pan by way of the strainer housing. This pump has its own manual shutoff switch. Now, onward and upward to the lube oil cooler. This thing's made up of a core, which is surrounded by a steel tank and has a header assembly at each end. The core is made up of tubes and fins. The cooling water is sent through the tubes, and the lube oil is circulated around the fins and the tubes. The water comes in here through these pipes at each side of the upper header, and it goes out through an outlet in the lower header, and the oil comes through an outlet at the other side of the lower header. If the cooler needs to be fixed, send it in to a qualified shop. You don't have the equipment that's needed to fix one of these things out on the rig.